Welcome back, everyone. This is BSP here with another Powercore experiment. Ever since I got my Powercore, I've been thinking about hooking it up to my mini lathe. I can't actually think of a legitimate reason for wanting to do that, however. Another thing I wanted to try is cutting through some tungsten carbide, but I don't really have any pieces of tungsten carbide I would be willing to sacrifice just for a cutting experiment. Then I remembered I have a bunch of brazed carbide lathe tooling that performs so poorly that I'd just forgotten that I had it. Maybe, if I could get it sharpened up, it would actually be useful. Cutting geometry on these cheap tools is completely wrong. You can see that the corner is almost completely square, and it needs to have a relief angle ground into it. For my cutting tool, I'm just going to use a piece of copper pipe that I squared up on the end. Make sure she's running true. I've repurposed the tungsten carbide contactor block from the wire tool kit to make contact with and energize the spindle. I have a 3D printed magnetic bracket that just holds it in position on top of the lathe. Just a quick continuity check with the multimeter to make sure that we have good contact. I have a 3D printed tool post to make sure that the tool is electrically isolated from the frame of the machine. The angle is built into the 3D print, so all I have to do is clamp the tool in and go for it. I'm connecting the tool to the Powercore with a piece of EDM wire so that it will act as a fuse in case I run the workpiece into the electrode. The plastic tool post will make sure that I'm not touching the machine because even though I am contacting on the spindle, the bearings will back conduct through the entire frame of the machine, so it does need to be isolated. I am using so the machine will only be powered on when I will be able to do this. I have a 3D printed flushing head and water collector to recirculate the deionized water back and make sure that I'm continually flushing over the junction between the electrode and the workpiece. It magnetically attaches to the ways of the lathe. I'm connecting the tube for the deionized water feed. I have my flushing connection on the top that sprays right down onto the mandrel, right at the point where the workpiece will be. Just like so. I've got the wire, hook up to the tool, got the other wire, got the other wire on the spindle, I've got the pump and the return line that comes from the sump down at the bottom there, so that all the water should be returned. And there we go. The enable port on the Powercore is hooked up to this manual switch. And now it's time to test. Let's see if we can make some sparks. So, how would I rate this project? Well, I think we have to give it a 10 out of 10 for irony. Cutting through the carbide tool with the soft copper pipe is about as good as it gets. As for practicality, I think we have to go 0 out of 10. The cast iron and steel parts of the lathe do not like being covered in DI water. I had to disassemble the lathe completely and dry everything off very thoroughly, and even with that, rust spots were already starting to form on the machine, and it took some scrubbing to get it clean again. Do not recommend. As for effectiveness, well, it does appear that we are cutting through the carbide material, so I have to give it about a 7 out of 10. Actually does remove carbide, if slowly. Jankiness score, we gotta go 7 out of 10. I have some nice 3D printed parts here, so it could definitely be worse. However, this is a manual lathe, which means I need 2 hands to operate it, plus the 3rd hand for the enable switch, and that's definitely adding points to our jankiness score. Also, since the terminals on my enable switch are not potted or protected in any way, and my hands are getting wet from DI water, I'm getting a constant 12-volt buzz on my knuckle as I'm pushing the switch. Also, good for our jankiness score. So that makes our aggregate score 6 out of 10. A cool project, but not one I can recommend, and one I don't think I'll be repeating anytime soon. Because my drip tray is filling up with my DI water because there's enough water running off the tool through other places, not going to the catch basin. So I drained the drip pan back into the reservoir, and I'll keep going for now. In hindsight, I think that the water that was collected in the drip tray picked up a lot more contamination than the stuff that fed back to the system, and putting it back into the reservoir was a significant source of contamination, resulted in my cutting performance dropping dramatically. And now let's pull the tool out and take a look at the results. Yeah, we are definitely cutting through the carbide. It looks like we have indeed ground a nice flat surface at exactly the angle we intended to. And that edge doesn't look too bad either. I'm not sure what causes that goldish tinged hue on both the cut surfaces. Neither the carbide nor the base material of the tool actually has that color, so it must be an artifact of the EDM cutting process. And now I'll switch the tool direction and work on sharpening the front face. Switch the other face. There's a significant color change in the water from when I started, and I've noticed that cutting performance is degrading, so I'm swapping to a clean jug of deionized water. And 3, 2, 1. Oops. Well, that was a close call. I think all the magic smoke stayed inside the Powercore, so I'll be able to come up with a less janky setup and give this another shot some other time.